It's the end. It's the final day. Anyway, welcome to space, YouTube viewers. It's the final day of spring. It's the first day of the rest of your lives. So, welcome to the Smash News Network, least busted name in news. We've got this fantastic composite imagery here. This is 171 plus 335 angstroms from the Solar Dynamics Observatory. Bunch of sunspots. The radio flux at 144 solar flux units. Likelihood of coronal mass ejections nearly 100%. We'll get to it toward the end of the video. And here's 94 angstroms. The likelihood of solar flares much higher as these large sunspot groups are approaching the limb, and you can see indeed increased solar flaring as forecast. Today's featured product is all of them. You can find links below the video to our merch shop. Thanks to everybody who supported the channel via merch. Universum Liberate to each one of you. Mansa, make America not suck again. Mensa, make Earth not suck again. Pick up some merch. It's fresh. If you haven't watched us on Twitch, we stream live to Twitch nearly every day. And we've already streamed once by now. And by the time you see this on YouTube, we will have streamed twice. Now, 2 days ago, on June 18th, we put up a post on smashomash.com/smashteam explaining how stars really work. So now that's only for gold level Smash Team members, so we can't show you the post. However, I would remind all of our gold Smash Team members you would have access to that post. We've explained the major basis for our paper explaining the solar sunspot and solar polar field reversal cycles. So welcome to the Neo Renaissance. It'll probably be the most important science paper in hundreds of years, at least as far as the natural sciences go. You can find links to the Smash Team page at smashomash.com as well as below this video. And let's take a look at the earthly geospace. It's Earth's magnetic moment from space. That's the last 4 hours of magnetohydrodynamic pressure, and we still do see a high-speed coronal hole wind stream showing up. Once again, as forecast, that's our Geospace Magnetosphere movie. So that was Earth's magnetic moment from space. Here's Earth's magnetic moment from the ground in nanotesla magnetic flux density. And those dark red areas, those are the most likely places to see both, not just the aurora, but also power line induction, pipeline and rail line induction. Yes. Electrical current from space. The KP index at 3. We've seen a bit of a negative BZ signal here, so let's take a look at the real-time solar wind and show that. The KP index for you new viewers is a measurement of global geomagnetism. So here's your real-time solar wind, and you can see this primarily negative BZ signal here. That's raised the KP to 3, but we see the field dropping off in strength here. So this white line going from 10 all the way down to 6 nanotesla. And it looks like we may see a subsiding here of the coronal hole high-speed stream, although we still do see elevated solar wind speeds at 534 kilometers a second. Solar wind density about 9 protons per cubic centimeter. Let's move into the realm of magnetic data. There is the GOES magnetometer. 2 GOES magnetometers. The GOES 16 and GOES 17. And maybe smoothing out a little bit here if that coronal hole high-speed stream is subsiding. Next, we're looking at the polarity of the heliospheric current sheet. The plasma coming out of the sun is polarized to one pole or the other. Earth remains in a south pole current sheet shown here in red. Next, our line of sight plot, and we're watching the solar polar field progression happen. It's called Solar Cycle 25, and it's been overperforming, or you could say outperforming most estimates. And let's move to coronal holes. We've got some very well-defined coronal holes here moving into the Earth-facing zone. Shown here in red, they are South Pole-oriented coronal holes. And let's take a look at it visually from the SDO. This is composite imagery in 93 and 193 plus 211 angstroms. You can see those well-defined coronal holes there rotating in from the east. They'll be moving into the directly Earth-facing zone, and we can expect some significant high-speed solar winds from those. Also, huge plasma filaments around the earthly-facing zone of the sun here. So quite a bit of stuff going on, and let's move to sunspots. Likelihood of solar flares very high as these major sunspot groups approach the limb. Also 3038 certainly capable of producing major flares. And let's take a closer look. A much closer look. Here's 1700 angstroms from the SDO. So these have mostly remained stable. It looks like the leading umbrae here of this sunspot group, that's 3038, these leading umbrae are moving a little faster than the trailing umbrae. I do believe that increases the likelihood of solar flares from that sunspot group. We also have this oddball sunspot located almost exactly on the solar equator, looking like perhaps a remnant from solar cycle 24. And let's zoom out here. Most other sunspot groups have remained largely stable, and we don't have any new groups rising in the east or anything like that. Here's the zoomed out view to show the full solar disk. We won't spend a lot of time on that. Let's move into the realm of solar flares. So the largest flare of the past 24 was this C5.59. Peak flux was just earlier this morning at 6:20 on June 20. It's the final day of your spring, or if you're in the southern hemisphere, of your autumn. Summer approaches, or winter approaches, the solstice approaches. No relativistic particles. And let's take a look at the 131 angstroms. Spectacular imagery here. That's the last 24 hours, if you're wondering. And while other YouTube channels claim the sun is going to kill you, they're blundering. So here's your star chart. If you're up before dawn, you'll see this incredible planetary pileup consisting of Saturn, the Moon, Jupiter, Mars, Venus, and Mercury all rising ahead of the sun. If you've got a low horizon and clear skies, go check that out. It's quite a lot of heavenly bodies up there as all the planets gather on one side of the solar system. And let's do a one-week forecast as the moon phase goes from gibbous waning to crescent waning. There's where things will be in a week. In a week, we are approaching another new moon, as we're wont to do. Next, looking at some coronagraphs, and again, we are expecting some coronal mass ejections. Let's take a look at some more imagery here from the SOHO LASCO C3 located at Lagrange 1 and the Stereo A Core 2 Space Weather Beacon. Stereo A's coronagraph located here on the left showing us a huge prominence here on the far side of the sun. So, from Stereo A's perspective, Earth would be off to the right. So this is nowhere near Earth. However, we can expect this to eject any time. That is a huge prominence, and there's no way the magnetic fields can sustain that much plasma. Expect to see that ejecting soon. Otherwise, pretty calm as far as coronal mass ejections go. Let's close out the video with the house favorite 171 angstroms. Once again, give Smash staff a raise by picking up some merch, becoming a member of the Smash team, supporting the channel that way. We also still are on Patreon. Visit us on social media, links on the homepage at smashamash.com as well as below this video. Thanks for tuning in to the most in-depth space weather on the entire internet, the most spectacular imagery of the sun on the entire internet. It's what we do at the Smash News Network, least busted name in news, and may that solar wind be at your back.